Okay, Matrix. So today we're going to be doing mechanical analytical. One of you guys did comment saying that the sound is a little bit bad, so I'm going to try to be a little bit louder. I'll hope to get that fixed in the future for you guys, but let's just get started. So this is for paper 2 of the June 2023 exam, and this is your mechanical analytical paper. Well, you're not your mechanical analytical, just your mechanical paper, but we are doing the mechanical analytical question. So it says here, given the 4 views of a combination square assembly, detailed views of 6 of the parts, a part list, a title block, and a table of questions, the drawings are not presented to the indicated scale. Instructions: complete the table below by neatly answering the questions which refer to the accompanying drawings, the title block, and mechanical content. Alright, so when you answer these questions, please always do it in print format. It's neater to read, and I believe that's the way they want you to do it. So just make sure that you absolutely do that. You need to do it. And let's just get started. So you'll see they've given you your parts, your part list, and your little title block as well, and the orthographic projection. So this is obviously third angle, and they've basically given you everything that you need on this piece of paper. Okay, and what you need to study to answer these questions are your mechanical analytical questions, as well as the papers that come before them in your workbook. They generally have quite a lot of information for you guys based on those drawings. So I can't basically show that right now, so I will make maybe like a cheat sheet for you guys that you guys can download or something for future. Perhaps not for June exams, but maybe for by the time prelims comes around. Okay, so we have who checked the drawing. So we are going to have a look at all different information, all the different information they've given us. So they've given us a company. Okay, there we go. It says checked by Lisa. So your answer will be Lisa. Okay, what is indicated by the number 058? So we have to find that number now. Don't mind me while I just look for it. Okay, drawing number 058. So that's pretty simple. That will be your drawing number. And they do this so that if a client had to email you and say to you, hi, you gave me the plan or information for XYZ, can you please pull it up for me? The drawing number is, then you type it in and it pulls it up in your system. Okay, so it just makes things easy to find. Then it says what is the title of the drawing, and if we have a look here, it says title combination square. So your answer will be combination square. Okie dokie. Now it says who is the client, so now we have to look again for our answer, and again it will be where it needs to be. So let's just have a look. Commissioned by Precision Tools. So Precision Tools is obviously the client because they commissioned the drawing. Okay, so you're going to write down Precision Tools, and remember, it's not always people that want plans. It is often companies as well. So just keep that in mind, because sometimes you look for a name and then you can't find a name and you start to panic. You don't have to do that. Okay. At what temperature is the ruler accurate? So we're going to have a look. Ruler accurate at 20 degrees Celsius. Okay. And that is over here. All right. From what material is the spirit level manufactured? So you're going to find the spirit level. It says here material glass, so you know the material is going to be glass. All right. How many lock nuts are required for the full order? So you're going to have a look here. Lock nut. Okay. Quantity. No, that seems a bit bizarre. Hold on a second. Okay, so this is why it seems a bit bizarre. Per combination square, 2 lock nuts are required. So this is important. But here they want 1,500 combination squares, which means you're going to times by 2 to get the amount of lock nuts, which means there will be 3,000 lock nuts. Okay, so I hope that didn't throw you off, because they do trick you like that. So it's important to read every little thing possible. And sometimes it does happen that you read this and you miss this here. So in your reading time, I believe they give you guys reading time before your papers, and they should give you that, and they do give you that in finals. Do actually read your paper. Remember, if you want to save yourself some time while you are busy reading, you could essentially find the answers. You can't write the answers down, obviously, but you can find them and keep a mental note. Okay, these are the answers. So when you can write your paper, you are just like, oh, okay, awesome. I already know where my answers are. Boom, 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 boom. You filled out the question. You've saved yourself 5 minutes instead of looking for it, right? So use your reading time wisely. Okay, what orthographic projection system has been used? Whenever you do a paper 2, it is always third angle. So your answer will be third angle. And you should know that regardless of which paper you're doing, mechanical is always third angle. Okay, what is the complete label name for view 2? So we have to find view 2. So this is view 1, view 2, view 3, and view 4. Okay, so just keep in mind that just keep in mind that because you're doing third orthographic projection, you are going to follow the third orthographic projection system. So we know here, just to give you a kind of an indication, I'm going to draw it up here quickly. You have front, top, right, left, 45 degrees, 45 degrees. We obviously have our top. Okay, this is another part of the top of view 1 and view 2. So view 2 will obviously be our right view, but because it's sectioned, we're going to say sectional right view. Okay, sectional right view. And please answer yours in pen. No? Don't answer it in Koki. That's what I meant to say, because I'm using a Koki so that you guys can see, but I believe you guys can answer yours in pen or pencil. Okay. What type of section is produced by cutting plane RR? So you're going to find RR, which is over here. And if you have a look, it does kind of like it goes up and then it bounces and it goes up again. So I'm going to actually just highlight that in case you can't completely see it on this paper here. So RR starts here, it goes down like that. This is one of the sections that will be in those front information pages of your textbook that you should be studying. So it is actually called a multiplane. So you can write that down. And they call it a multiplane section because it's happening on multiple levels, right? Okay. Then it says what type of section is indicated at A. So we're going to find A. Okay, here we have section A, and that is called a revolved section. Again, it's in your front information pack, so please do study that. In the front of your workbooks, you should be given like a page with all the different types of sections and all sorts of things like that. Okay, and then we have the next question, what type of section is indicated at B? And that's this over here, and you can see it's been taken out, and that is called a removed section. Okay, then it says determine the complete dimension at C, D, and E. So let's just find them. I always struggle. Okay, C, if we have a look here at C, we have to look at, these are our parts, these are our lock nuts. Okay, so you're going to use these measurements to basically determine these measurements here. So if we look at the complete thickness of this over here, it would be, that's the height. They don't give you extra information here, do they? Yes, they do. It would be 17, right? Because if you look here, this is the same, and that is 17. Okie dokie. Then we have section, oh, number D, sorry. And if we find D, that is this over here. And we need to obviously find the full measurement of that little section over there. So what you will have to do is add up all of your parts by the looks of things. So this is looking at it from the top. So it's going to essentially be from here all the way down there. So if we just have a look at these measurements here, I'm just trying to see quickly now, so don't mind if I'm just going a little bit quiet. I just like to double check so that I can show you exactly where it is. If you've got a look, so yeah, do you see, like, there's your lock screw, there's your lock screw over there, right? So you'll have to add your lock screw together with your scriber, with your spirit level, I believe, as well. Your spirit level. I'm just trying to see where they're sectioning everything. Your lock nut, your spirit cap, spirit level cap, your spring. So basically, you're going to add these all together based on what you're looking at here to see the full length of everything. And then once you have done that, like here, you see there's the length of 8. So that would be like the length of 8 over here. You would be able to get your measurements. And just so you guys know, the measurement is 111. So yeah, but you do have to add all of these together. It's a little bit of work, but that's how you're going to find the answer. Okay, then it says what is the dimension at E. So let's just find E quickly. Okay, E is over here. So this one's pretty easy because you've got the full length of 46, then you're going to say minus 29 minus 3, and that will obviously give you a dimension of 14. Okay, so now they have the next question: how many surfaces of the combination square assembly must be machined? Now, this question throws a lot of people off because they don't often know what that means. And if you have a look here, this is the symbol that we use when something needs to be machined. And what often throws people off is when you have to machine double sides, right? So here we have 1, 2, 3, 4, because you can see the 2 arrows over there. Then we have 5, 6, 7, 8, 9. So here they've been pretty nice with with your question because everything has been shown. But sometimes they give you a question where one of these are hidden. Like, you just need to assume that if you machining the one side, the other side would be machined, right? So the only way I can explain it to you is if you have a cube, for instance. So let's just draw up a cube here quickly, and they show that this side needs to be machined. That's the incorrect symbol, sorry. This side here needs to be machined. You would automatically assume that the other side needs to be machined as well, right? So sometimes they trick you with that, so that's why I'm just letting you know. Then it says, what is the correct label for view 4? And if we have a look at view 4 here, we know that it is a detail because they're pulling something up and enhancing it so we can see what it is. So we call it detail T. Okay. So we're going to write that down. And the reason why we know it's detail T is because over here you've got T, you've got a little circle around it as well. So let me just highlight that quickly. So there's your circle, and there is your enhanced detail. Okay, what finish must be applied to the surfaces of the lock nut? So we're going to have a look at all of our notes again just to double check. Diamond knurling, okay, so that's what you're going to write down there because that's obviously your lock nut, and you know that because you're going to read this over here. So there we go, you're going to write that down. Knurling. I feel like that's such a weird word to say. Okay, with reference to the tolerance, determine the maximum and the minimum dimensions for the dimension at F. So here we have F, and they give us the tolerance over here, which means that the maximum you would add this measurement here where it says plus, and for the minimum you would minus. So I'm not going to work that out because obviously I've already told you how you're going to work it out. But if you had to write that out, you would have 0.103, 0.025, and then you would say that would be the max, and then you have 10295, and that would obviously be your min. Okay, Then it says, on the ruler, in view 1 only, add in neat freehand sans convention for the interrupted view. So let's just have a look. Okay, the sans convention for the interrupted view, and that is, where did they say? In view 1. Okay, and when you have an interrupted view, where is it on view 1? Oh, yeah, because this is the full view 1, and that is why they want you to do it, because when you don't have the correct things on your drawing, it becomes a bit confusing, right? So basically the sans convention is this squiggle here, the one that looks a bit like a lightning bolt. Please draw yours properly. I'm just freehanding mine. Please make sure yours is correct. But it's this little symbol here, if you don't know what I mean by the lightning bolt. Okay, and basically what this shows is that the view has been broken and interrupted, which is why when I was looking at view 1, I was looking here thinking, well, what am I supposed to draw, right? So that's how they confuse you, and that's what I'm trying to get at, is that you've got to look for these little tricks, if you want to say that. Okay, with reference to the machining symbol below, question 19, that's this over here. Match the letter on the symbol with the correct label in the column to the right of this question. So it is important for you guys to know this. It is in the front page of your workbook again, which I cannot show you at the moment. So I will make like a study sheet to kind of like pull that out and then show you guys what you need to know. But for now, I will just answer the questions for you guys. So direction of lay will be L, because that is the symbol for direction of lay. So you're going to say L. Then it says roughness value, and your roughness value is G. Okay, then they want your production method. Your production method will be J. Okay, and the last one is machining allowance, and that is H. Okay, and then it says a quarter of a symmetrical base plate is shown on the block below. On to 20. Complete the view by adding the sans convention for symmetry in neat freehand. And so basically what that is you are just going to draw a dashed line. Okay, like this here, and then you're going to have to do the freehand as well. Okay, this should be done freehand, not with your ruler. Okay, and anyways, that will then be your question complete. So I hope this helped you guys. I know mechanical papers for me personally were like one of the more challenging papers, and that's really just because of these bits here. But to be honest with you, it is very easy if you practice and if you read your papers in the front of your workbooks and things like that. And also just practicing a lot of past papers will help you get used to how you should answer these questions. So with that being said, I hope that this helped you. If there's anything that you need me to change, do, would like me to cover, let me know. I do get very busy and sometimes I don't really know what I can do to help you currently. So your comments will help me and they will help you, because I'll be able to make videos more relevant to you. Okay, so I hope this helped you guys.